In today's tutorial, we will discuss two examples where the solvation shell takes a profound influence on a reaction. First example, here we have a tertiary bromide, in addition in a benzoic position. It is an enantiomer with A configuration. We have a polar solvent and a nucleophile which is sterically somewhat shielded by the three ethyl groups, triethylamine. In such a case, we would anticipate that a nucleophilic substitution takes place by an SN1 mechanism. That means that before the triethylamine will attack as a nucleophile, this molecule will fall apart into two ions, this benzoylic cation and the bromide on the other hand. Then the nucleophile will attack, and finally we will get such an tetraalkyl bromide as a salt, and now it's the question, will it be racemic or not? Since we anticipate an SN1 process and the probability of an attack should be equal from both sides, we would say, okay, this is racemic. In reality, we will notice that at least some part of an enantiomeric excess will still be present. Why is this the case? Well, we have a solvation shell around it, let's say an alcohol, then by hydrogen bridging bonds this bromide is stabilized, and within the shell it becomes more difficult to get away from the countercation. Still, it will remain close to the countercation and therefore will shield one side. So, therefore, the probability of the triethylamine to attack from the other side, similar to an SN2 process, will still be present. So, not complete racemization, but racemization to some extent is what we will observe in such a case. Second example, protonation of an aldehyde by a strong acid, in this case trifluoromethane sulfonic acid. Normally we would say, okay, those two molecules have to get together and the proton is directly transferred to the carbonyl group. But in the presence of a solvent, for instance water, this is not necessary. The transfer can be much faster since the water molecules work as a relay. Well, we have lots of hydrogen bridging bonds, and the acid can just deliver the proton similar to a billiard game, puts in the proton And well, all those protons just have to slightly move closer from one oxygen to the other. We have depicted that here, and very fast the carbonyl group will be protonated, although the acid is initially quite far away. So the solvent helps that the protonation is much faster in such a case with a protic solvent compared to the case without a solvent. Well, in addition, of course, you can anticipate that the second water molecule associated to the second free electron pair will move away as soon as the carbonyl group is protonated. Thanks for listening.